All right, 7.2, we're talking about growth. We're going to be graphing exponential decay functions. Last video we talked about growth, now we're going to talk about decay. And we're still dealing with exponential functions. Right. So your first objective in this lesson is you're going to be learning how to explain that the parent function for exponentials is f of x equals b to the x is supposed to be a b to the x, where b is less than 1 but greater than 0. It's very important. That right here, along with this variable in the exponent, makes it exponential decay. These two key parts, there and there, are important. And the other objective is you're going to be able to determine the horizontal asymptote of an exponential function when looking at its graph. Right? We know for exponential growth that the horizontal asymptote was our x-axis. Our horizontal asymptote was our x-axis. For decay, it's the same thing. Okay. Now we are, all right. I was going to say something else, but that's for the next video. All right, so let's look at what it looks like. Horizontal asymptote is the x-axis. Okay, so this right here, the x-axis, that's my horizontal asymptote. Now as x approaches infinity, really positive infinity, and what that means right there, it means going to the right. All right, so as I'm going to the right on the x-axis forever, that's what infinity means. Positive infinity means I'm going to the right forever. So I'm going to the right forever. So as I'm going to the right forever, my graph gets closer and closer. You notice my graph keeps getting closer and closer and closer to the x-axis, but I will never cross it or touch it. All right? Just like exponential growth. So key things for the graph, this is what the normal graph will look like, where A, if you notice here, is your y-intercept, just like before. B determines if it's growth or decay. If B is less than 1 but greater than 0, in other words, it has to be positive but less than 1, I have a exponential decay. Now if B is greater than 1, then I have growth. Alright? But we're just going to focus on the decay aspect because we already did growth. Alright, so classifying functions. Alright, so here's our exponential functions. Why this is exponential? Because you have a variable in the exponent. Remember, A is your y-intercept. B determines if it's growth or decay, just like I said before. If B is greater than 1, it's growth. If it's less than 1 but greater than 0, then it's decay. In other words, your graph will either look like this or it'll look like that. Tell whether the function represents exponential growth or exponential decay. All right? So when doing these type of problems, all you look at is the term that has x as the exponent. All right? Once you identify those, then you look at the base, or b. So in this case, 3/4. Is it less than 0 or greater than 0? 3/4 is less than 0, so this is decay. This one, 5/2, that's what, 2.5? So the 5/2 is 2.5, and that's greater than 1, so therefore this one's growth. 4, that's greater than 1, so that's growth. 0.25, that's less than 1, so that's decay. So that's how you determine how these graphs would be. Is it growth or decay? You just look at the term that has x as the exponent, then look at the base. Is it greater than 1 or less than 1? All right, what we're going to do now is we're going to graph 2/3. All right, so here A is still 1, because remember it's A, B to the x. And you know this right here is B. B is 2/3. So that means A must be 1. X is in the exponent. The variable is in the exponent. And B is less than 1, so it's decay. So it's going to look like this. All right, so what we do is we sketch our coordinates. A is your y-intercept, so here's 1. Okay. Now I want to pick one point on each side, just like I did before in the last video. We're going to use 1 and -1. So I plug 1 in, so 2/3 to the first power is 2/3. So at 1, I'm at what? 2/3, that's 0.67. So here's halfway, somewhere in here. Go at -1, plug -1 in, so I got 2/3 to the -1. Well, negative exponent makes it flip it, so it's 3/2, which is 1.5. So here's 1, here's 2, 1.5 BB right here. Okay. And you just come down and connect. Arrows in both ends. And that's all you do. So it's almost the exact same steps. Actually, it is the exact same steps as the last video. All right? It's just now you're going decay. Before, last video, growth was going something like this. All right? But now we're doing decay because we're decreasing. All right. Now what happens if I have A is negative? You notice here A is negative. All right. Well, graph is not going to be looking the same. It's going to be a reflection across the x-axis. All right. So what we do, well, A is -2. Here's 1, 2. So there's your y-intercept. Make a little t-table. Make it 1 and -1. So I'll plug in 1 in for x. So I got -2 times 3/4 to the first power. So that gives me -2 times 3/4. And -2 times 3/4 is what? So is -3/2, which is -1.5. So go to 1, -1.5 right here. Now we put -1 in for x. So I got -2 times 3/4 times -1. Well, -1 takes this right here and flips it. -2 times 4/3. So that gives me -8/3. So that's what, -2.67 approximately, anyways. Oops, throw my stuff. So -1, got 1, 2. So it's past. So it's somewhere in here. Now if I draw this to scale, it should look something like that. Because originally it should look something like this. But since it's negative, it's reflected over the x-axis. So this is y equals -2 3/4 to the x power. That's that graph right there. All right, last but not least, well, what kind of graph we here? Is this growth or decay? Well, A is equal to 4, so that means that's my y-intercept. All right, so go ahead and sketch that. So we go 1, 2, 3, 4. All right, now look at B. B is 1/5. That's less than 1, so it's decay. So this is decay. Okay, so make my little t-table. All right, put x is 1 and -1. If we plug 1 in for x, so I got 4 times 1/5 to the first power, which is 4 times 1/5, which is 4/5. So it's less than 1. It's about 0.8. So here's 1. It's not to 1 yet, but it's just underneath it. So we'll put it right here, approximately. Now we do -1. So we got 4 times 1/5 to the -1. Negative exponent takes this right here and flips it. So it'll be 4 times 5/1, which is 20. So now I'm way up here. All right. So it comes down. So my graph's not made to scale here. It's supposed to be something like that. Right, sorry for my bad drawing here. All right. It's not drawn to scale, so it's a little freaking out here. All right. So there's my decay.